I have here a very simple script, check.py, which is supposed to print either total and free memory or total and free disk available on my local system. Unfortunately, when I run it, it displays these somehow weird numbers. Let's fix this issue. You see here that script takes two arguments, M for memory and D for disk. Depending on its arguments, it may branch into this part or into this part of code. Let's first figure out if argument memory is set correctly and application branches into this part of code. Now, it is very tempting to add here something like this. But adding a print statement here is just wrong. Why? It is because if I add a print statement, later after I fix our issue, I won't need this statement anymore, so I will need to remove it. Depending on your application, spreading temporary print statements, which is sort of primitive debugging, will do you more harm than good. You may forget some of these print statements. You may add yet another bug when removing these temporary print statements. Long story short, when you find yourself debugging an issue and you want more information from your application, logger debug is the way to go. So I will replace this print method with logger debug. Now I need to declare logger variable. I will import logging module first. Then I will configure logging module with debug level. And then I will instantiate a logger instance. And if I run my script now, it prints checking memory. So it branches into this part of code after all. But before we continue debugging this little script, let's first figure out what I have done here and why debug function prints messages with this prefix. Loggers in Python are hierarchical. They are organized similar to Python modules. Here I have illustrated my script structure. Check.py uses code from memory module, which lives inside app module. Python loggers are conceptually arranged in similar manner. And exactly like Python modules, loggers hierarchy is expressed with dot notation. So app.memorylogger is a child of app logger. App.disk logger is a child of app logger as well. In Python, special variable __name__ gives you the dotted notation of current Python module. Thus, if you use logging getLogger function called this way, it will return a logger named app.memory if you call it from within memory module, and it will return app if you call it from app module. This automatically structures your logger into hierarchy. You may think that having tree-like structure for logging is an overkill. In case of a small script like check.py, you may be right, but in pro version of this lesson, where I will teach you advanced logging techniques in Django project, I will show you how, in the context of more complex projects, this logs hierarchy becomes a lifesaver. But let's focus on check.py script. I will add one more logger instance, this time in memory module. So here in memory module, I will import logging module first. And then in similar manner to check.py, I will declare logger variable. And you see here in check.py, I declare memory class. Let me add some debug messages here. And now you may realize that what we have here after debug log level is actually the name of logger instance we use. Inside extract function, there is a if not line return 0. I will add even more debugging information to double check that this part of code is reached at all. Let me try run check.py again. The first line matched, and second one matched as well. And by now I kind of think I know where's the problem, because we have here many digits, but when searching within regular expression I have only one digit. So add here a plus. And let's check now. Okay, great, now looks like more realistic numbers. I reached a very important point. If I used print statements for debugging, now after I found the bug, I would need to remove all print statements. But using logging module enables me to leave debug statements where they are and just mute them instead. By leaving debug statements where they are, they may come handy during next debugging session. What I want to do now, I want to add another argument. I'll call it verbosity, which will toggle logging level from debug to info. Let's do that quickly. And now, depending on this argument, I will change debugging level from info to debug. Note that default value is 0, so if I won't add anything, the verbosity argument will be 0. And now I'll move this configuration line from here at the top to this place. Let me now check if code works. Okay, with verbosity 1 debug statements are there, and if I remove it, no debugging statement. Great! Takeaway points here are following. It is a good practice to use logging module. Every time there is an opportunity, use it. Declare it, let's say at the top of the module using this form. Another point, a less obvious one, is that you need to configure logging module only once. I mean in one single module. In the example of application I showed you earlier, I configured in check.py. Once I mentioned logging module configuration, let me show you something really cool. Instead of configuring logger using functions call, you can load logger's configuration from a YAML file. Let me show you what I mean. I will entirely remove configuration part first. Also this argument, we won't need it anymore. And here at the top of check.py module, I will add code to load configuration from a YAML file, like this. Now I need to import YAML and logging config. So entire configuration of the logging subsystem, so to speak, happens here, and it loads configuration from this YAML file. Check logging.yaml file looks like this. It must have version specified, and for some reason this version is always 1. Each of the loggers I want to configure will be under this key, loggers. So my application has this logger __ main __, which I set up as debug level, and app.memory logger, which I set up as info level. Both of these loggers will use this handler, which I called XYZ console, and XYZ console is configured here. This thing here means display logging messages in the console. If I want to redirect the output to a file, I'll do like this. So if I will run my script now, it will display all its output into this file, check.log. It should display only checking memory. Let's verify that. Maybe you noticed check.log appeared here. Right, so only checking memory is displayed. And if I change handler from XYZ file to console, it will display output to console. I hope you enjoyed this lesson. Thanks for watching.